invite Dr. Amzad Hussain Laskar. Dr. Amzad Hussain Laskar is an associate professor at the Physical Research Laboratory, PRL, Ahmedabad. He received the Best Research Scholar Award from the Indian Society for Mass Spectrometry 2011, the Academia Sinica Postdoctoral Fellowship 2013-15, the Marie Sklodowska-Curie Fellowship 2017-19 from the European Union's Horizon 2022 program, and the Eminent Visiting Scholar Award from the Netherlands Earth System Science in 2023. He has started the Frontiers in Geosciences Research Conference, FGRC, and successfully convened 3 events in 2021, 23, and 2025. I invite him for his talk on the hydrological dynamics in giant tropical rivers, a case study of the Ganga River.
Good afternoon to all of you. This is the last talk. First, I would like to thank the organizers for inviting me, giving me opportunity to talk. And the previous speaker probably made my life a little bit easier because she already tuned the science discussion. Most of those discussions, science in the sense traditional way what we think. So most of the discussions are more like field-based, but her talk and probably my talk is also mostly data-based, experiment-based, and then some mathematics also involved. I will try to avoid mathematics. So the title of the talk is Hydrological Dynamics in Giant Tropical Rivers. So I chose Ganga because we have completed the study, but of course we have carried out some study in Narmada as well. So I will discuss some of those studies as well. So I am Amjad from PRL, and these are my collaborators. So they include people from academics background to policymakers, so all. These are some initial studies in Narmada Valley, mostly related to the carbon dynamics, then paleoclimates. So I'll go through some of those briefly. So these are the 2 paleoclimate studies which I conducted almost a decade back. So these are the reconstruction of the past climatic conditions of this lower Narmada Valley, as well as vegetation reconstruction. I won't go into details of this because today's topic is different. Not only that, we have recently started one work to rejuvenate what are the action plans to rejuvenate the springs and shallow aquifers in the Narmada source region, Amarkantak. There are 18 villages in the Amarkantak plateau which depend on spring and shallow groundwaters. But because of this topography, physiography, of course, these waters in those regions don't reside, so they immediately run off. And then those springs are mostly seasonal. So how to improve them? Okay. So isotopic analysis, we did carry out isotopic analysis in all those spots. We did multiple collections in different seasons, and we found that some of them are very potential recharge zones. So where we can increase the recharge, okay, and then we can probably provide better fresh water to those people. Those are mostly tribal communities. This is another study which we are doing in association with the Gujarat Water Resource Development Corporation, GRWC, GDRDC. So these are the groundwater dynamics of the entire Gujarat. So we carried out all the way from the recharge zone at the foothills of the Aravalli Hill to all the way to the Gulf of Khambat. So we carried out radiocarbon measurements as well as stable isotope analysis along with various chemical analysis to understand the dynamics. What do we mean by dynamics here? We estimated the radiocarbon age or the residence time of the water in various multi-layered aquifers, from shallow to the deeper wells, deeper aquifers, and then assigned radiocarbon ages and estimated what is the flow rate, where the potential recharge taking place, what are the most vulnerable zones. Not only that, we also did some analysis of the seawater intrusion in the coastal regions. So we estimated what is the flow rates and all these things. I don't want to go into details. And as pointed by one of the speakers yesterday, that some of the shallow aquifers are drying. Yes, we also observed. Probably 2-3 decades back, if you go, there are artesian wells were there, free-flowing wells. Just you put a pipe, water is coming out without any pump, anything. But no longer they exist now. And many of the aquifers, shallow aquifers, are dry now, particularly in non-monsoon time. This is another study related to the carbon sequestration, carbon dynamics in soils of the Gujarat. So we carried out detailed analysis we measured the samples collected samples from all the way to the tip of the south of Gujarat to the north. Not only that, some forest areas, for example, Gir forest as well as the Ratan Mahal Beard Sanctuary. So what we observed is that these agricultural soils in the Gujarat are carbon depleted. 90% of the carbon, whatever was present around the mid of the previous century, lost. So those agricultural soils are a source of carbon. We also estimated the turnover time of carbon in those places. And we also recommended what are the steps we should take to increase the carbon sequestration in Gujarat, maintaining those whatever the farm and crop activities, whatever we are carrying out. So this work is under review. Most of the work so far, the studies were field-based. Our studies are mostly lab-based. Okay, so we do go to field, but so these are some of the experimental facilities at PRL. So this first one is the stable isotope ratio mass spectrometer with laser ablation, various type of peripheries. This is one of the biggest facility in the country. Accelerator mass spectrometer we have, where we have, this is probably the important connection between archaeology and geology as well as physics people. So not only that, we also develop our in-house systems, experimental systems. So these are the vacuum systems used for various type of analysis, isotope ratio as well as radiocarbon measurements. Now I am coming to the topic of today's talk. So it is about the Ganga water dynamics. So Ganga is very important. I won't read all this. Okay, so you all know that this why Ganga is important and all these things. Only thing what I want to emphasize is that despite its importance of Ganga, it is under existential threat with very less summer base flow. In many places, you can just walk across Ganga river. Pollution, of course, human interference, declining biodiversity, and overall environmental degradation. So what are the reasons? What are the steps we should take? I will discuss with data and more quantitative way, not qualitative. Okay, so the objective of the study, quantitative estimation of the loss of water due to evaporation, okay, interaction with groundwater throughout its course, contribution from different tributaries at different river segments, and impact of groundwater level change around the Ganga river, how it influenced the base flow of the Ganga, particularly in summer. So this is the map showing the Ganga, location of the Ganga, its tributaries, and these symbols show the points where we collected the samples throughout the Ganga. That was done in 2019 or 20. Okay, so briefly, I know many of you don't like these mathematical equations, but just briefly I will tell you what we have done. We use isotopic fractionations. What do you mean by isotopic fractionation? So suppose you take the 2 lakhs molecules of water. Out of these 2 lakhs molecules, you will find that this 99,800 are 60 no. Only 200 will be 80 no. Natural abundance. Now if you evaporate that water, so number of the 16 and 18 molecules of water will not maintain the same proportionality. So if you just evaporate water at 25 degree, you will see that this 2 number of water 18 molecules less in the vapor. And that we can precisely measure with a precision of probably 1 in 10 to the power 6. So ppm level. Okay. So that's what we expressed using mathematical equations. So this is called Rayleigh equation. Suppose if you are a reservoir, if you remove some of the materials, and then how this reservoir will evolve. It is explained by this Rayleigh model. It is not that simple. For us, it is, in this case, actually a single reservoir, and there is a removal of the material. But if there is a addition of the material in that reservoir, then how it will become. So it will become more complicated, and this is the mathematical equations. So it is fairly complicated. So I don't want to go into details of that, but just I would like to tell you why we consider this equation. So here this is the schematic of the this model. So here what is happening is that in the case of river, stream water, there is a input which is coming from the groundwater, particularly in this case, and there is a loss due to evaporation. So this is a analogous to this, and this is the equation dealing with this. So now, how we do that? How we calculate that? So we have to estimate the fractionation. How much is the fractionation? Fractionation can be both equilibrium as well as kinetic. I don't want to go into details. So you combine equilibrium and kinetic part, and then we can estimate how much is the evaporative loss from the river stream. So if you just measure the isotopic composition from one spot and measure the isotopic composition another spot downstream, we can calculate how much water is lost along in this stretch of the river. Okay, so these are the actual isotopic data. So we collected the water samples from source Devprayag of the Ganga to all the way to the Ganga Sagar. Of course, the Ganga Sagar data is not there, Howrah. Okay, so this Alaknanda and Bhagirathi, so these blue symbols are the tributaries. So you can see that in the upstream region of around 150, 160 kilometers in the top regions, there is not much change in the isotopic composition, but as you go down, there is a change in the isotopic composition. That is because of the evaporation as well as the interaction with the groundwater. So that I will give you the actual estimate, quantitative estimate, how much. That we estimated using those Rayleigh models. So these are some of the very basic things in the case of hydrology. We measure the meteoric water, we check the meteoric water line. What is meteoric water line? You just plot the oxygen and hydrogen against hydrogen, and then you compare with the global meteoric water line, and then you can, from that you can tell you what are the processes happening within a system.
Sorry, one second.
Yeah.
Ganga and soap. After in this summer, as the ICA, you have those so that.
I will probably discuss that in one of the later slides. Yeah, that also is an important thing. We also address that. It is there. I will tell you that. I am not presenting that today, but that we also estimated. That is called hydrograph separation. How much is coming from ice melting? How much is coming from groundwater? So all these things we have done. That is, I have a publication on that as well, but not in this one. But I'll. Yeah, not. So that I will just briefly tell here, but not the data I am not presenting here. We also modeled how this delta 18 and dxs should change under different this relative humidity and temperature conditions. So these are model mathematical, mathematics, and this we related with the actual data, and we found that this dominant process here is the evaporation. Okay, so the summary of the findings, that evaporation, around 58% of the Ganga water is lost due to evaporation. In its middle stretch means around 200 kilometer long, this middle stretch from Haridwar, Bijnor to all the way to the Buxar or Varanasi. So this is the plain region of 1200 kilometer long. So this is downstream, and this is upstream is around 150, 160 kilometer. The river water volume increases by 120%. So what do you mean by 120%? Means if you take 100 ml of the water, starting from the beginning of the middle stretch, by the end of the middle stretch, it increased to 220 liter. 100 liter to 220 liter. That means because of the groundwater contribution. So how much groundwater is mixing or discharging into the river, that we estimated. And in the downstream region is dominated by the tributary water. So this Gandak, Buri Gandak, and then this Gagra. So these are the rivers which joins the Ganga in Bihar. So they contribute maximum. They dominate the river. In situ. Now another important thing is that how Ganga depends on the groundwater. Whether this groundwater depletion is causing a reduction in the Ganga flow. Okay, so that also we did a detailed study based on the groundwater board data. So now the process is what is happening. Before going into that, what are the processes, what is happening in this Ganga. So in the upstream region, it is dominated by the glacier and snow melts. We have a separate study, but here I am just showing that for a length of 160 kilometer, it is dominated by the glacier and snow melt contribution. In the middle plain region of length 200 kilometer, groundwater is mixing with the river, evaporation is taking place, and in the downstream it is dominated by the tributary water. We also did the groundwater level data study from the Central Groundwater Board. We did a detailed analysis of all the wells present in this Ganga, middle Ganga plain particularly, to understand how this groundwater level changed in the last 20 years. So we only took the wells where more than 50% data are available. For example, in the last 20 years, more than 10 years data are available where about the. And we found that in some places, even these are pre-monsoon and post-monsoon, I believe, some places there is an improvement in the groundwater level. In some cases, there is a decrease in the groundwater table. Okay, so overall, there is no significant, not a drastic change in the groundwater level. So why it is so? That is a controversial statement, I would say, because it is well known that this groundwater level is going down in most of the places in Indo-Gangetic Plain. So here is the data. We studied more than probably 700-800 wells, and we found that this groundwater level decreased in 198 out of that in monsoon, and in pre-monsoon around 336 wells. Okay, and in the case of, there is an increase in the groundwater level in some of the cases, and no change in most of them. So you can see that this more than 80% probably there is no change in the groundwater level. So now why this Ganga is drying? So it is well known that Ganga is still drying. So the reason is, first is that this diversion. Most of the water is diverted at various places. Upper Ganga canal near Haridwar, and then middle Ganga and lower Ganga canals. I won't present the data here, how much is water is diverted, because the Ganga is a transboundary river, it is very sensitive. So those data you cannot reveal. Okay, so that's why, but just believe me that this majority of the water, most of the water is diverted. Satellite data are there with large uncertainty are there. But still, I don't know whether it is advisable to publish that as well, I don't know. Being an Indian citizen, I thought that I don't want to touch those sensitive issues. Okay. So, and decrease in inflows from many tributaries and rivulets due to human encroachment. I'll give you example of a few. This river Gomti in Lucknow, you will see that it has been reduced significantly, substantially during the recent time. Baruna in Varanasi, so this type of many such rivers and rivulets, they have been actually encroached, and uncontrolled pumping of water. You just pointed somewhere that this in the previous during the previous theft of water, there's a lot of loss of water that is covered here in this third point. So now, what are the recommendations? How can we improve the Ganga condition? So we have to release first thing is that we have to release the water, increase the percentage of water released at various dams, barrages, so at least 25% in non-monsoon time. So for making a river a sustainable one. Okay, so the extinct tributaries, particularly third and higher order tributaries and rivulets of Ganga, we have to rejuvenate them. Human interference should be reduced. Lot of human interference taking place. Strict regulation on disposal of untreated industrial and municipal wastes. If you go to Kanpur, you will say that this Kanpur city, there all the sewages, everything is directly dumped into the Ganga. So that makes the Ganga very polluted. Population probably started increasing from Kanpur onward. Then local storages such as lakes, ponds, wetlands can be restored to increasing the groundwater recharging condition, and reduction of pumping of water directly from the Ganga river. And evaporation loss can be minimized, probably with some measures. So this has implications not only in the case of Ganga. This Narmada canal, which we discussed a lot, It passes through very dry, hot, less humidity of course dry conditions. So lot of water losses will be there. In the Ganga in 1200 stress, 58% water loss we estimated. So someone can estimate how much is the loss from the Narmada Canal, Sardar Sarovar Dam to all the way to the end of this Narmada Canal. So I'll stop here. So these are the people working with me. So these are students and postdoc, and this is my mentor. He superannuated recently, Professor M. E. Yadava. I'll stop here. Thank you.
With your books, could work on one more hypothesis. There are certain bacteria in the gut which becomes important.
Do you guys?
Yeah, I have a close connection with Namami Ganga team. We have the data. I have the data. So I started writing, but then I thought that probably this will become a controversial issue.
Have got the data citing to this are you? Come on, they.
Yeah, I know that. So I have several years data, including all this fecal coliform. So all other bacteria data. Yes, I have. Yeah, thank you for encouragement. Probably I can think of doing that. In PRL, actually, it is not like that. I am independent, kind of stuff. I am at PRL. Oh, he was at PRL. He superannuated 1.5 years back. This person. I was working with him, did my PhD as well as the initial phase of the, but no longer, he is no longer in PRL. So he superannuated and then left PRL 1.5 years back. He's Professor Madhusudhan Yadav.
I know all the origins of giants.
Okay.
Sorry.
Sir, I have also one question. In one slide, you have mentioned like in middle part, groundwater in Ganga river is mixing. But in upper and lower, why you did not?
Yeah, important question. I did not show the data for that. See, in the upper part of in this part, the Ganga water, the level of the Ganga water is above the groundwater table. That is one thing. Second thing is that this is very steep part. The strong slope is there, so water flows very fast. So water does not get much time to mix with that.
But what about this downstream?
Downstream, we observed that it is other way. Ganga river is recharging the groundwater, this aquifers. Even during the summer.
But that area is also plain, sir. No?
It is plain, but because this major tributaries, this Gagra, Ganga,
yeah.
So they are flowing a lot of water to the Ganga, and this amount of water, whatever is here in this, probably 70-80% is, I have the estimate, is contributed by these rivers, Gagra, Ganga, then Son, and some more rivers, I don't remember, tributaries. So that's why the water level here, this water level is high, and then this water is recharging the groundwater. So that we estimated using electrical conductivity. Simple electrical conductivity, if we measure, groundwater it is high because of rock and groundwater interaction. But in the case of river water, it is low. So if we just simply plot, you can see that where this interaction taking place.
On the basis of EC only, you have...
No, here we use more sophisticated isotopes.
Okay.
But if you just simply use electrical conductivity, then also it will give a similar estimate.
Okay, fine, thank you.
Yeah, Vikrant.
Yeah, just one or two questions. You mentioned about 120% increase in discharge, and that reflects groundwater contribution. Have you also estimated the loss in canal? You're doing this estimation, or groundwater contribution will be much more?
I didn't get...
So I mean the upper Ganga canal and lower Ganga canal also extract lots of water out of the Ganga river. So when you are saying the 120% increase in discharge, It is after reconsidering the canal values?
After removing that. So because
Yeah.
that is not contributing to the downstream.
Yeah.
So now whatever start, for example, this Upper Ganga canal, from Upper Ganga canal, how much water it is released, you just consider that as initial. Now from that water, 58% is lost because of evaporation. Okay. And then there is at the same time there is an increase because of the groundwater discharge into the river. And that increase is 120%.
Okay. So your increased values at the point of Upper Ganga, or is it at the glacial region?
At the end part, at the end of this middle stream,
At the end of middle stream is the initial values.
before the
Okay.
confluence of Ganga probably the major big river
Okay.
which joins Ganga. Yamuna is probably in summer it is not that significant.
Okay. And yeah, second data is regarding to the season. So does it indicate the post monsoon values, or like monsoon condition, this 120% or variation?
No, it is pre-monsoon time.
It is pre-monsoon.
The reason why we do it in pre-monsoon, because that is the most important time when water availability is very important for all this day-to-day purposes.
So this is a lean period condition where you are observing that groundwater is
Pre-monsoon time, yeah.
But during monsoon period, maybe rainfall.
Yeah, we are planning. Actually, we have some data, so I didn't present here. Yeah.
Okay. And the last question about, you mentioned about upstream part. It is a glacial contribution is dominant. So what is the meaning of dominant in terms of percentage?
Yeah. So if you go, for example, very close to probably the here, more than 50%, 70% estimates are there. So, but if you come down, probably it decreases. So probably here I would say around 50% is glacial contribution. At the beginning of this, or around the end of 150 kilometer, here it is somewhere around 70%.
Okay, but 50-70% is very high. Consider the other paper which talks about for the Ganga river, it is around 20%.
But that will depend in which
season
spot. Yeah.
So you are considering during the melting time period, summer time.
Yeah. So, but if you come down here, probably you will not even see 5% of the water is contributed by the glacier.
And everybody should be inside.
Okay. Thank you. Oh, okay. Yeah.
Yeah, I can ask without question. So thank you for the presentation. Okay. Thank you for the presentation. Help me out if I'm not clear about the question that I have. So you have taken the river water samples, isotope analysis of that, or you have also considered the groundwater?
Both river water as well as groundwater.
Okay, so the 58% that you have mentioned, that is for the pre-monsoon period, the evaporation losses.
Yeah.
That you have calculated with dxs, if I am right.
We calculated using oxygen delta 18O.
Okay.
Delta 18O.
And how did you ascertain that, besides you told about the EC value, how did you ascertain that the river is gaining it at that middle section with only with the isotope data?
Yes. That is based on just delta 18O.
Okay.
So we know that is what is the delta 18O value of the groundwater around the river, and we measured in the river water. So we know that this how much is the change because of evaporation, and at the same time what will, if we add, so it is a two component, not two component, probably three components. One is there is a input and there is output. So we use that model, and I showed a long mathematical equation.
Okay.
We use that one. So there is a term where beta n input and n output. Material added, material lost. So lost is we used a different equation to estimate, and then how much is the added. So you numerically solve that.
Okay.
Sir, other parameters still also affect like alkalinity, hardness. You have already measured acetate.
Okay, thank you.
Hardness won't probably affect isotope much. Yes, of course, hardness is one thing, but that thank you.
We shall now disperse for the short tea break.
I know we want to go.
Sorry.
So thank you very much, Dr. Laskar, for this wonderful talk. So yeah, just before the tea break, since we'll have the valedictory address, I just want to give the vote of thanks. And first of all, I want to thank the organizers. Of course, our own Dr. Kanungo, he was the mover behind this, and he brought many of you here. So let's give him one applause. Pranav is not here, Pranav Mahapatra, but he also, being the convener of the Sea Narmada, has been very supportive of bringing interdisciplinary dialogue and really supporting that engineering, earth sciences, geology, and humanities and social science should come together. And this is the ethos of our institute, and this is what I think this conference was really about. So, and also I want to thank the PhD student organizers for all your help. So Azim, Tanya, and Richa, everyone. So thank you very much. Let's give them one. Okay. Just to say brief things about the esteemed delegates or the themes that came out of the sessions before we get to the valedictory address.